So let's talk about how to find the inverse of a function. So how do you find the inverse of a certain function? So there we go. Now one thing I want you guys to understand is that you can only have the inverse of a function if at all the function is non-singular. Do you know when we say non-singular, we're talking about the function is not singular. So whenever we're talking about a matrix that has got which is a singular matrix, then the determinant is 0. Okay, so a singular matrix has got the determinant, or let's say we have got matrix A, the determinant is 0. I'll give you a very simple example. Let's say we have got a certain function or certain matrix which is maybe 2x, or let me use 2k. Then we have got 3, then 7, then 1. Then they ask you to say find the value of k given that the determinant, or given that the matrix is singular. So just know that whenever we're trying to find the determinant of a singular matrix is 0. So whenever we're trying to find the determinant, you have to multiply the minor diagonal minus major diagonal. These are what we call the major diagonal, and these are what we call the minor diagonal. So in this case, you have to say 2k times 1 minus 3 times 7, then this should be equal to 0. So that will be 2k minus 21 is equal to 0. So 2k will be equal to 21. So divide both sides by 2, then 21 divided by 2. So the value of k is just 21 over 2. So basically, when we're talking about singular matrix, this is what it means. Okay, so like I've said, a matrix can only have inverse if it's not a singular matrix. If it's a singular matrix, it can't have an inverse. Okay, so let's say we have got matrix A. Now we're going to start with talking about 2 by 2 matrix. So how do we find the inverse of a 2 by 2 matrix? Let's say we've got matrix A, which is 1, 3, 2, 4. Okay, now we want to find the inverse of this matrix. Inverse is represented by, if in this case it's A raised to the power negative 1, that means it's an inverse. So this is the same as 1 divided by A. Okay, so the basic idea behind inverse of the function is this. So this is how we find the inverse. The first thing is you write A raised to the power negative 1 should be equal to, so it is 1 divided by the determinant of matrix A. Okay, then everything times, now the major diagonal you multiply it by negative 1. Okay, so the minor diagonal in this case is, we have got 1, 4. Then the major, you have to multiply it by negative 1. So this will be negative 3, then this is going to be negative 2. Okay, that's what we do. Now another thing is we need first to find the determinant. So how do we find the determinant of matrix A? We are finding the determinant of matrix A. So the determinant of matrix A is the minor diagonal. So it's 1 times 4 minus 2 times 3. Not so. So it's 4 minus 6. That is giving me, it's giving me what? It's giving me negative 2. So the determinant of matrix A, so we'll say A raised to the power negative 1 is equal to 1 divided by negative 2. Then 1, negative 3, negative 2, 4. Now another thing is we just need to multiply 1 over 2, 1 over negative 2 multiplied by everything inside there. Now 1 by 1. So A to the power negative 1 is equal to This is negative half. Negative half times half, that still gives me negative half. Then this one, negative and negative will cancel. Negative half times 3, negative 3, it gives me 3 over 2. Then negative half times 1 times negative 2, that becomes 1. Then negative half times 4, that becomes what? 2. Okay, so this is the inverse of matrix A. Another thing that you need to know under inverse is this: if at all I multiply A times A inverse, what I should be able to get is an identity matrix. Now, what is an identity matrix? An identity matrix is a matrix which has got identity matrix is just basically a matrix that has got we have got what we call, it should be 0 if I've not forgotten. It should be 1 0, then 0 1. This is an identity matrix. Okay, so that matrix, we call it identity matrix. So if I multiply this guy, multiplied it by the original, that one, I should be able to get this one. So that is an identity matrix. Okay, now I believe you are able to get something. Yeah, so that's basically how we find the determinant of a matrix. Now let's try to have another example. Okay, let's try to have another example. So another example is going to be like this. We have a matrix that is given that we have got matrix P being equal to 1 2, then you have got 2, then you have got 3. Now this matrix, we want to find the determinant, sorry, the inverse. Remember, the inverse of matrix P, which is represented by that, is given by 1 divided by the determinant of matrix P, then multiplied it by these minor diagonal, they remain the same, then these we multiply it by negative 2, the major diagonal. When you do that, let's first go ahead and find out the determinant. So the determinant of matrix P is equal to, let's see, so it's 2 times 1, 2 times 3, sorry, minus 2 times 2. That becomes 3 minus 4, that is negative 1. So this becomes 1 over negative 1, which is basically negative 1 just. Okay, so negative 1, then 1, neg 2, 3, then you have this. So P to the power 1, negative 1 times this, that becomes negative 1. This times that, that becomes 2. This times this, negative, I'm now multiplying this with each, so I've multiplied by 1, negative 1, negative 2, that is going to give me positive 2, then this one will give me negative 3. So this is the inverse of this matrix. Now, if you guys have gotten the logic, let's try to answer this. Let's say we have got matrix Q. Given that matrix Q is 2, 3, 2, 4. Now find the inverse. Now find the inverse and give me the answer in the comment section. I'll be able to check it out. So this is basically how you can find the determinant or the inverse of a 2 by 2 matrix. Okay.